got what I think is going to be the last kind of reading group thing for chapter 1 of the physics book. Okay, cool. We're live on YouTube too now. So yeah, both of the usual suspects who would be in voice are out today. So I think I'll, unless like Fembox you or someone who wants to hop in, I'll just kind of go through the book and choose a problem and do it on the whiteboard like I would do normally. Actually, were the worst problems that I called out, maybe I can work on those problems. 15, okay, well, I called out like 15 and 16 having to do with like Gauss's law. Let's take a look at those and see if... Okay, yeah, we did the flux through a circle. Okay, let's take a look at 16, I think. It does explicitly say Gauss's law. Two pointers Q are located at positions x equals plus or minus L. I would switch to the Discord whiteboard, which I don't mind either. Or if you want, you can like hang out and chat and just jump on and talk it out with me if you like see me making a mistake or taking the wrong approach or something. I think I saw Stooky doing this problem on stream. I wasn't able to pay much attention though, so I don't really have any hints. I think it'll be good to try this one. Yeah, Femlux, I don't mind either way. Real whiteboard or Discord whiteboard? Think you prefer the real one? Okay. I mean, I'm neutral because like on one hand I like the feel of the real whiteboard, but on the other hand, with the Discord whiteboard, I don't have to like get up and stand. So I'll just go use the real whiteboard and extend the invitation that if you want to hop on voice now or at any point today and either just talk about what's on my real whiteboard or use the Discord whiteboard, you're welcome to do that. Two pointers here located in x equals plus or minus L, close to the origin on the x-axis. You have to make approximations here. What? My headphone cord is stuck on something. Oh, 1 second. Oh, it's stuck. It's stuck on my PC case. Aha. That'll do it. Okay. They're both Q. That's length L, curly L. Okay, so this first one is just a normal, like, for part A, it's just like Coulomb's law. And part B is going to be the Gauss's law part. So close to the origin on the x-axis. To assume exactly if we add the origin, it's going to be 0 here, but I guess this is, we don't even have to do a points close to the origin on the x-axis. Okay, good. I thought you were saying close to 0, 0. Ah. Who got first? Waffle, nice. Welcome in, Waffle. So the tricky bit here for me is like the vectors. That's what I am kind of trying to puzzle out. So if we call that x, the force from this charge on the ray is going to be stronger. So we have Q 4 pi epsilon naught L minus X is the distance. Should maybe color code these. I mean, this math should work for either direction, but this is how I'm approaching it, and then I'm assuming I'm going to get something that works for X being on either side of the origin. We need to worry about our vector, though. It's a unit vector. Oh yeah, happy Saturdays all around. So this vector starts at L comma 0, ends at X comma 0, and is a unit vector. So the entire vector would be, well, it's pointing left. I guess it can always be X minus L, comma 0, because it's perfectly horizontal. With this blue one, it would be a negative L over here, I guess. So it's going to become X plus L. But then what's the magnitude of that is just X minus L, isn't it? Oh, so the unit vector is 1, 0, I guess. That's kind of weird to think about. Negative 1, 0. Huh. Okay. Actually, wait, it's E sub X. What am I talking about? I mean, I guess this is still E sub X, to be fair. Like, I should just not do the vector stuff at all if we're talking about E sub X on its own. Do I need a cosine theta on this thing? Like, I feel like I shouldn't if we're fixing x to always be on the x-axis, but I feel like we kind of always do it anyway, so I'm going to put a cosine theta on it. If you like it, you should have put a cosine theta on it. Okay, so that's pushing, I guess, to the left. Maybe so, should we slap a negative sign on that, or was that coming from the cosine theta? I think that would come from the cosine theta. Because I'd say that that's theta equals pi, I guess, which gives us a -1 for cosine. And either way, these are going to be subtracted. I feel like I'm overthinking this. I don't know if I'm underthinking or overthinking, to be honest. Like, can we say that's the blue one? And does this work for when x is on the other side of the origin? I liked it enough to put a cosine on it. If x is negative, well, no, these signs do get flipped if x is negative. But really, these are the same expression. Just one has a sign flipped and one doesn't. So no matter where x is, I feel like we just switch our red and blue if x is negative and we're fine. Like these aren't so different. And I just want to plug in values for theta right now because I don't want theta to be in the answer. And I wonder when are we going to need approximations? Maybe for the y-axis is where we actually need approximations because this just seems kind of, well, I guess, Okay. Can I just like have a 1 over? I'm going to plug in pi for theta and 0 for theta and flip the order. I feel like this is what I want. I've heard them explaining it though. This is, like a lot of this E&M stuff is just me having some kind of instinct that I can't explain. If x is much less than L, isn't this 0? Yeah, because right at the origin, it should be 0. So if we're talking about close to the origin, it's pretty close to 0, I guess. That doesn't seem unreasonable for me to get. I don't know if I got there in the right way, but the E sub y should be the harder calculation anyway. Well, You want to get common denominators and then simplify the numerator? Oh, I misread your thing about saying it's 0. I mean, I can do that, but if I got 0 here, maybe the approximation will come out different if we get the common denominator. We can see what that looks like, I guess. L minus x squared. All right, so we get L squared minus L squared is 0. Minus 2xl. We get a plus x squared and a minus x squared. We get a minus 2xl. It's the 4 is going to cancel. Let's stick a minus sign out front. Just xl, x plus l squared, l minus x squared. Now if we do the approximation, that's basically L squared times L squared and L over that. So 1 over L cubed. I don't know if that's right. Times x? Oh, I guess that's true. The x on top. Yeah, because x times L, a small number times a big number actually does affect things. We shouldn't just chop that off. A small number added to a big number isn't significant, but a small number times a big number, that is significant. Okay. That's fair. Yeah, that makes sense to me too, $10. I think I wanted to go with that answer, and the negative sign in front doesn't worry me too much because it just depends on the value of x. I would expect it to be a negative value for positive x because the red charge is stronger there. So I don't mind this answer. All right, so let's work on, I guess, e sub y now. It's interesting that it's L cubed on the bottom. That seems strong, I guess, but you can go with it. Okay, so here, their forces are going to be adding straight up, or their fields are adding straight up or straight down. They agree with each other now. So Q over, really, I think we just multiply by 2 and not, worry too much about it. We do have a right triangle that gets formed. I should probably not be lazy and actually draw that, right? So the hypotenuse of the right triangle is y squared plus L squared. Sine theta. And sine theta is y over the hypotenuse. I said y over the hypotenuse, so y, the hypotenuse is the square root of that, so we get y squared plus L squared, so 3 over 2. I don't think that's unreasonable, I hope. Hey Viv, Vivipin, how's it going? Now similarly, if y is much less than L, this y on top probably stays, because it is going to depend on y. But down here, we can say, we get another L cubed. Because L squared to 3 over 2 is L cubed. Huh. Interesting, okay. So I guess I'm going to call that part A. Let's look at part B, which was the actual Gauss's law part. Consider a small cylinder centered at the origin with axis along the x-axis. The radius is r0 and the length is 2x0. So yeah, this flux stuff. Is going to be the challenge here. Hey Bode, the best feeling is finishing school. Oh, are you all done? Or are you just like looking forward to it? Axis along the x-axis. You're done? Oh, congratulations. Hope you enjoy your break. Wait, so are you like a done, or are you just like on summer break? The radius is r0, the length is 2x0. Wait. Yeah, the radius is r0, the length is 2x0. Okay. Okay. So I think we need to verify the flux through this thing is 0. Summer break, you're still first year in high school, which is 16. Oh, okay. Well, I hope you enjoy your summer. Verify there is 0 flux. See, I don't want Suki to carry me through this. 'Cause I don't remember if I actually even learned flux in multivariable calculus the more that I thought about it. Like the way the book explained it, I thought was really nice. But I don't remember actually like learning about it. So I've been kind of winging it. The flux is still E dot dA though. And we expect to get 0. So I don't think we're gonna have anything coming through the side of the cylinder. We only have things going in at either end. Oh, we finish in the US in high school. It'd be, yeah, usually like the first or second week of June. University finishes maybe like late May. Hey, Quack. I do, but not right now. On Saturdays, usually the first 2 hours are dedicated to doing this physics studying. If you have a quick question, Quack, I could try to answer it, but if there's anything involved, I'd ask that you come back either in 2 hours or another day. Or not 2 hours now, but like an hour and a half. Now, I assume we're going to use our approximation here, like... Could we make a field vector, or could we make the, Or maybe not. Maybe am I thinking about it wrong? Yeah, Fembox, that's what I was like. I was getting a little mixed up on that. You're back in 2 hours? Okay. It's not that easy? Okay. How do we calculate this? When it's entering in, it's like passing right through our solid. Or it's passing through like two parts of the solid. Do we split it up into the two end caps and then the sides? So we're going to get 3 integrals. I would think that any vector you can name from this charge on the right is going to have like basically an equal and opposite vector on the left here. It's going to be the overall point. No integrals? Just the approximation per A. Really? Okay, well, so we're saying maybe then the field through either of the caps is going to be this X. Is equal to field L cubed times pi r naught squared. Flux through left cap is the same but positive because it's pointing the other way. Like, I'm talking about like the net, I guess, because there is flux on the left end cap from that right charge, but this thing we already found for E sub x accounts for that. That's what I'm going to say, I guess. Um, 4 pi epsilon naught L cubed, and the side of the cylinder. Those 4s shouldn't be there. Why not? It's what I got in my formula. Did I mess up in the part before this? Two pi RH is the area of the side. That makes sense. I'm just gonna follow through the calculation. Oh, you're hopping in voice? All right, I'll hop in. Hey.
Hi.
So I guess what's wrong here?
What I can see is on the last line of your calculations for EX.
Yeah.
Now I might not be reading it correctly, but it looks like I
Oh,
don't think there's a 4 there, is there?
I did randomly add a 4 there. Okay, you're right. I can fix that. Yeah, because I took the 4 out and then I just added in for fun. Oh, it's just a weird pi. Oops, it's my own bad handwriting. Actually, yeah, there's a 2 there. 2 pi R0 2x naught. Okay, other than that, are you kind of like on board with what's happening with like we're breaking up into pieces and then
Yeah,
these are going to be
the other
opposite
thing I was going to
signs?
say was I thought that you might want to plug in X0 in your formula for the right cap and left cap, right? Because we were evaluating that electric field at
Oh,
those
true.
values for X.
Yeah, that's.
And I think that's what takes care of that negative sign too.
Uh,
For the left cap, right? Like when you
yeah.
said
Either
that
way,
for
they
the
have
left
opposite
cap, the
signs.
negative would go away. And it's because we're plugging in negative X0 there, I think.
Okay, yeah, that's fair. So yeah, we could say like a to make it more clear. Minus negative x naught. And this would be like q minus y. Well, that point would be R0, I guess. Actually, if I'm only considering the top half of the side, I guess we have a 1/2 there. That's not really that important though, because they'll both have it. Yeah, that gets more important as all these sum to 0. I think I'm going to check out the answer in the back of the book.
So if we add those all up, does it work? Should we check it? Because I think if we factor it out, I mean, it might.
Well, do we need to do any factor? Like these two, they just have opposite signs, but they're otherwise the same, and the same with these.
We could take out q over pi epsilon naught from everything, right? And the L cubed as well. That comes out.
I guess why would we? Because we like.
Well, just to make it easier to add these four terms together.
But aren't each of these pairs becoming 0 anyway?
Oh, I see what you're saying. So there's no need. It's just trivial. Oh, yeah, gotcha. I see
Yeah,
it.
okay.
Yep, fair enough. Fair enough. Of course they are. Sorry.
No worries. I guess to see if the book agrees.
Huh. Well, wait a second. I'm confused then because that's not what I was expecting. I was expecting we were going to get a net positive coming in through the two sides, the two circles, and then that same amount was going to be negative going out through the curved side, right? That's what I was thinking. I wasn't thinking the left and right circles would cancel. That doesn't seem right.
I guess it's only the x components that are canceling in the circles.
Oh, wait, you know what, Don? Wait a second. I just realized something.
Yeah.
E dotted with dA, right? Ah.
Oh, right. That's why we only take the x component, yeah.
So for the dA, that's a signed vector, isn't it? That's an inward pointing, well, is it? No, it's an outward pointing to the closed surface. So the dAs are always pointing out from the surface.
Right. So the sides only care about the y, and the caps only care about the x. I think. I didn't do a good job of writing that on the board, but I didn't realize that either until you said it.
So the flux through the right cap is fine because the dA is pointing to the right, but the flux through the left cap, we have to negate it because the dA is pointing left. Yes. Okay, makes sense. So those two fluxes through the left and right cap will have the same sign.
Well,
what I mean is they won't cancel, right? When we add them together, they won't cancel.
And well, no, and for both the caps, the field is going into the cap. So either way, if the cap's always pointing out, we're always opposing it.
Yeah, the field's pointing
so they both get
in.
negated. So if only one was negated, we wouldn't get the cancellation.
Right. I'm kind of imagining in my mind that the Q's are positive charges, right? I think that's how you've set it up too.
Yeah, they said charge Q, so I was taking it as positive.
Yeah. Yeah, so E is pointing in and dA is pointing out through both those circular caps, right? So the flux should be negative for both of them. I guess what I'm saying is the flux through the left cap will be a negative times a negative times a negative. I think there's three negatives, and the result would be a negative still.
Yeah, I guess what I've written is like the magnitude of E times the magnitude of dA. Or, sorry, the magnitude of A. And I'd have to put that like cosine theta on, which will both be cosine pi, which is -1. So don't change the result. That's like more right, I guess, but we still get the same cancellation.
Really? It just doesn't feel right.
Well, the area vector points out from either cap, and the net field points in because whatever charge is closer dominates. So the angle between them is 180 degrees.
Yeah.
So I'd say E dot, we can just take one big area vector, I think, for this. Cosine theta. The magnitude of E, we can just take the positive version of what
There
we
we
got.
go. There we go. So that gets rid of the negative from that Q,
R naught squared.
from our formula.
Actually, is this? Well, wait. Now we won't get the cancellation. If we do it for if we do the same thing for the other cap.
Yeah, but the magnitude of E strips off the negative sign from our formula, and it also strips off the negative from the XO that we plug in, right? So
Yeah. Isn't what I wrote not good then? First, we're not getting the cancellation anyway, unless there's something else.
yeah, I don't think they're going to cancel. But what I think will happen is that the sum of the fluxes through the caps will be equal in magnitude to the sum of the fluxes through the top and bottom. That's what I was thinking might happen.
Well, we don't know the relationship between X naught and R naught.
X naught R naught squared. Yeah, but I can see that all those four terms are X naught times R naught squared, right? So the hope is that all the coefficients will just add up to 0.
All right, I guess let's try it. Right slash left. Top slash bottom. So the magnitude Q R naught 2 pi epsilon naught times 2 pi R naught 2 X naught is a half. Now cosine theta, what's the angle between these two?
I think that's good. I think that's right, right? Do you think that's correct as it is? I think it's right.
I feel I think we need to sub the cosine or something. Like there's probably something we can do with R0. Well, not for cosine, I guess that's opposite. Like it shouldn't just be 1 because they're not parallel.
I think it's just 1. Yeah, that's what I'm thinking.
So the normal vector to the surface on top points straight up.
Yeah.
Oh, if we're right on the y-axis, then yeah, these two fields do point straight up the y-axis, I guess. When you add them.
I mean, I think that they want us to assume we're close enough to the origin that all these things are like that we don't need the theta right here anymore, right? We're just assuming they're parallel now.
Yeah. So I guess I almost wrote the 4th again for X. Wow. Cubed. the pi's cancel. R naught squared with a negative sign. And a 2, because we have a right and a left. This is messily written. Plus 2 times this. 2 pi cancels, 2 with the 1/2 cancels. Q R naught, X naught, epsilon naught, L cubed. Oh! I didn't put the 2 in front, did I? Yeah, because the 2's all inside cancel, but we put another 2 in front because we have a top and a bottom. Oh wait, we have an extra R naught here for the Y though. Can we deal with that? Actually, no, we have an R naught squared. Oh, and actually, oh good, that matches. Okay. I guess you're right. The X components cancel the Y components.
Yeah, so it equals 0. What goes in must come out.
Okay, that makes sense. And hey to Christian, and hey Jed, and Critical. I don't really know chemistry beyond the bare basics. I think Gold is the person who knows chemistry the best. I don't know the limits of what he knows though. It's number 16.
I feel good about this one.
Yeah. So for the X part of part A, minus QX, 4 pi epsilon L cubed. Hell yeah, same exact as I got.
You even get the negative, nice.
Yeah. Oh, they did the approximation a little different though. How does that work? Oh, they did some weird, what? I don't know how they went from this line to this line. They factored the L squared out of each denominator?
Yeah.
Must have been? Okay. In Critical, yeah, this is physics. Okay, well, it gets to the same result. That's a weird math technique, but... The Y component, QY, 2 pi epsilon naught L cubed. Awesome.
So the Y has a 2 in the denominator, but the X didn't.
Yeah. And it ends up being okay. Should be valid for all points in space near the origin. Oh, I guess, yeah. If we're slightly above or below the x-axis, the y still doesn't matter all that much. Similarly with being close, but not going to be on the y-axis. And that's, I can better justify the cylinder part, I guess. E sub xy is an even function of y. E sub x is an even function of y. Okay. Sure, yeah, it's symmetric about the y-axis. And if you move up or down, that does affect the x direction of the field.
Yeah, I get that. So if you change y to negative y, you should get the same field strength.
Oh yeah, I think they're saying like changing x to negative x, but I think that's true also. If they're saying it's an even function. E sub x, xy has no linear dependence on y. Hey, Sarthak. I haven't heard of those, so I guess the answer is no. JEE Advanced Physics questions? I haven't. Okay, so they do a lot more justification for why we can use the approximations we just made, but the point is that they do work for things that aren't exactly on the x and y axis, or x or y. Okay, they set this up in a weird way, but I think it comes out to be the same thing that we got.
Yeah, they just sort of factored all that stuff out and called it C just to make it a little tidier to write it down. But yeah.
I guess so, yeah. Okay. Well, nice. Thank you for the help there. I guess we can go look for a new one. Do you want to keep hanging out on voice, or do you want to like just pop in again if you feel like you have something to say, or?
What's easier? If I stay in voice, does it mean you want to change the setup somehow?
I can keep using the real whiteboard if you don't care about writing for yourself. I don't mind doing either way.
What's quicker? Is it quicker? Is it quicker to use the Discord whiteboard? The only reason I said I preferred the real one is because when you guys were using the Discord one, it was a little harder to read it. You know, it seemed like it
Oh,
might be
really?
hard to. Well, I don't know
Um,
if it's harder to write on that Discord one. I haven't never tried it. And I know there was three of you writing, so I could never tell exactly who was writing, but sometimes some of it wasn't as easy to read, was all.
Yeah, yeah, that's because it's hard to tell like how it comes through on stream, I guess. We can let's just keep using the real board, I guess. You can correct me, I guess. If I'm going off the rails.
Somebody in chat mentioned the Wacom tablet. Christian said, "Have you used a Wacom tablet?" And it's I actually have one. I thought I had one here, but I don't. I think it's at work. But they're those little tablets you can hook up to your computer and use to with a stylus to do writing.
Oh, okay. It would be like easier to do those, but I just like the feel of the real whiteboard.
Yeah, I don't blame you.
So I'm looking at a potential energy one. I don't know, did we do 32? No, we did 31, which is related to 32, I think. Oh, and start
Yeah,
that?
31. We tried 31. We didn't get it, but we tried it.
Oh, okay. I'm still okay with looking at 32, to be honest. Unless you want to open the case for 31 again.
No, 32 looks good.
Okay. I was interested to hear Sarthak about JEE. I'm probably gonna stick with this stuff that I'm doing, but if I feel like I get good enough at physics, it might be a nice like way to try some problems. Okay, so hollow spherical shell with radius r has charge q uniformly distributed over it. Show the energy stored in the system is q squared over 8 pi epsilon naught r. It's equation 1.53 to find the energy stored in the electric field. Huh. Part B looks super weird. We're constructing a hollow spherical shell with even smaller shells, or like thinner shells. I guess we can worry about part A first, but what is 1.53?
Yeah.
Okay, epsilon naught over 2 times the integral of E squared dV over the entire field. And dV is going to convert to dA?
No, I think it's still dV.
You might be right.
Because I think with that formula, we're not integrating over the charged region. We're integrating the electric field over all of space, I think.
Oh, that could be it. So you do the potential of a uniform sphere, and I wonder if the case for inside a sphere is going to be relevant. The field at radius r, and well, that's from that's not from the shell itself. But this is qr 4 pi epsilon naught r cubed. How similar is that to the result we're supposed to get? Q squared over 8 pi epsilon naught r. And it's kind of different.
If it's a hollow sphere, then it probably will be zero inside, won't it? The electric field?
Right.
So we probably just have to do so we probably just have to integrate over all the space outside of it.
Well, like, I guess how does that work? Are we bringing in pieces of the sphere from infinity?
I was just thinking about part A right now.
I guess I meant that for part A, but I don't know if I don't know, I'm not sure how to set this up yet. Assigning amount of energy to every volume element dV, integrating over all space where there is electric field. Integrating over all space where there is electric field. Okay, see, I think that is what you're saying. So I guess we go from R to infinity, where the field will be.
Yeah.
Okay. And a hollow sphere is going to behave like a point charge, I guess. or
Yeah.
outside?
Yeah, I think it does.
Well, I say give us the result that we or the result to expect, so we can try it and see if we get the right answer here. Okay. Hollow spherical shell. Radius R, charge capital Q. Okay, so the field of this thing for small r greater than big R is Q over 4 pi epsilon naught R squared. I guess R hat. But we're gonna do E dot E anyway. This feels way too simple, but I think it's gonna get the right answer if we epsilon naught over 2. Wait, don't we just integrate this thing directly? dr and R goes from big R to infinity. Fourth dr. Q squared over 32 pi squared epsilon naught. Integrating 1 over R to the fourth is minus 3 times 1 over R cubed from big R to infinity. Oh, wait, we're not supposed to get our cube though. Hard luck, you sure are first. Congratulations. So I think I'm getting the result that like the book gets for a regular point charge.
I think you can use that formula for E, but I think we have to do some kind of triple integral in spherical coordinates, maybe. Like, I'm not sure you can just do, don't you have to do like R squared sine theta, dr d theta d phi or whatever? Or is that right? There's some.
I mean, I feel like it's one of those things where the book will make the argument that like the only unique direction is like radial is like the radial distance from the center, and everything's going to be the same. Like one of those like symmetry arguments where you don't actually have to think that hard. The book gets the field of a shell somewhere, doesn't it?
Yeah, I think we can still use that formula that you're using for E for the electric field strength, right? The magnitude of it. But I think when we want to integrate it over space, we have to do dr. I think we have to do a triple integral instead of just a single integral.
I'm not sure. Like in the potential energy example the book did for a solid sphere, they just boil it down to a single integral. We might
Oh,
need a
4
triple
pi
integral,
r
like you
squared. I
said.
see. So that's what we can do. We can multiply by 4 pi r squared dr. There we go. I guess
Oh,
that's the, I guess
yeah.
that's the same thing as doing like a triple integral, but they're just
They cut
they already
to the
know that they can
chase.
call
Yeah.
that 4 pi r squared.
Okay. So yeah, you're right. I did forget that factor. And I guess we do use the same, that's the surface area of the sphere, I guess.
Yeah, there we go. So that gives us the extra 2 dimensions we need.
Okay, I guess that's fair.
4 pi r squared, but it's a lowercase r, isn't it?
Well, the surface area is constant, isn't it?
The surface area that we're integrating over isn't constant because we're integrating over a sort of a series of expanding circles, spheres, to
Integrating over
fill
a
up all
series
of
of expanding
space, right?
spheres. Well, I mean, we have the one shell, and we're integrating the field over all of space.
Yeah. Okay,
I think
maybe you're right.
I think it'll come out to get the right answer, maybe for the wrong reason, but we want just an r to the 1 on the bottom, and I think this will get it. And hey, why do we? No, I integrated r, 1 over r to the 4th, 1 over r cubed. In that last one before I erased it. So that's just a 4. That's going to be an 8 on the outside. That's a good sign. Just pi, because one of the pi's cancels. Epsilon naught. Take care of the 4 pi, the r squared. Okay. R to the 4th dr. So we're going to put an r cubed on the bottom. And I think that's a good thing. Not. So that's going to be q squared, r squared, 8 pi epsilon naught, 0 minus negative 3, 1 over r cubed. I don't think that 3 is a good thing. I don't think there's a 3 in the answer. I gotta look at it again. Yeah, Bladby, I'll bring it in here in a second. Yeah, there's no 3. We're working on 32 here.
Oh, you know what I did? I integrated it, but I used 4 pi little r squared instead of 4 pi big R squared, and I think that gets rid of that 3.
Oh, really? Huh.
I think so. Of course, I could have screwed it up.
Oh, you're probably right. You said that we're integrating over the volume that that little piece of field occupies, rather than any
Yeah.
volume of the object itself. Okay. Okay. Yeah, that's fair. which means that's just r squared on the bottom. Does the... Oh, that gets rid of the r squared on... Ah, okay. Now that works. Okay. Okay, cool. So that's part A down.
Nice.
So part B, imagine building up the shell by successfully adding infinitesimally thin shells of charge dq. The energy needed to add on a shell. When there already is Q. So this is going to be, I think, a work. And we're going to be opposing the force due to the field. R and Q. And we have another infinitesimally thin shell dq that we're bringing in from infinity. That's how I'm interpreting this. And every one of these points on our new shell is going to be opposed by the field. We have to integrate specifically over Q. So this has charge dq over 4 pi r squared surface area. As I guess, sigma, I guess, would be the density, but I don't know if that's really important. Like, isn't Q saying the same? I don't get this integrating over dq thing, I guess. Or integrating over q.
That's lowercase q. I guess that's our variable now.
Yeah.
So I'm thinking we're going to integrate from 0 up to capital Q, d lowercase q, right? But I don't know what to integrate.
Same. So maybe it's not work, because if we have to integrate over q, that's just not distance. I'm trying to relate it to distance in some way with like that thing I did there, but I don't think that's helpful.
So maybe if we had so the whole thing's like spherically symmetric, right?
Right.
So if we've already got some kind of, charge lowercase q already there in a spherical, thin shell, and we want to bring another dq out from infinity, we could bring it in spherically symmetrically, right? Like imagine a giant sphere with radius infinity being shrunk down to a sphere with radius r plus dr or whatever, but we bring it in, we project it inwards from infinity, right? So
Yeah.
if we do it that way, can we say that the work done is just, so the whole way we're bringing it in, we're bringing it against the electric field. So how do you do that?
Yeah, I don't know how you do that with q. I feel like I figured out a way to do it with r. Because like we have to integrate over q, but when the charge already there is q, and then integrate over q. So I have it seems like a coefficient of capital Q, or I guess lowercase q. Well, I feel like it's going to be this with some kind of coefficient. Because that'll get us to a q squared. I'm just reverse engineering it, but... But yeah, if the charge already there is q, I feel like we would be... Our integrand would be q.
Oh, okay, wait, I have an idea that might work.
Okay.
So I'm just looking at the formulas from the summary at the end of the chapter, and I'm looking at the one for potential energy, right? So U equals 1/2 times the sum. Remember the one with the double summation in it? And it's 1 over 4 pi epsilon naught times Qj Qk over Rjk.
QK.
Okay, now, okay. So couldn't we call one of those Q's is just the Q that we already have there, the lowercase q, and the other Q is our dq, right, that we're bringing in from infinity? And the R will just be capital R, right? Won't it just be the radius of this sphere?
Well, R would be ranging from infinity to capital R.
Yeah, that's how far we're bringing it in, but the potential energy, which is the work necessary to bring it in from infinity, equals this formula. And so we're bringing it to a position where the lowercase r will just be the capital R, I think. And see, that would be nice because it would mean that we wouldn't have a variable with regards to position, right? Like everything's going to be coming to the same capital R endpoint.
Oh, okay, yeah, we don't have to care about it, I guess. Yeah. We don't have to care about like the path it takes. We just care about the final distance.
Yeah.
Well, I mean, saying it's R would be convenient, but like a point. What is the distance from a point on a shell to the rest of the shell? Sometimes it'd be 0, sometimes it's the opposite end of the shell.
Yeah, so
That's kind of
I'm
weird to me.
treating so what I'm doing in my head is I'm thinking of the shell that was already there as if it's a point charge at the origin, right? At the center of the sphere.
Okay.
I
And
don't
that
know
would
if
be a
that's
0.
legit. I don't
If it
know if
was a
it's
point charge, yeah.
illegal, but that's what I was thinking.
Um, hmm. Shell.
Yeah, I have a feeling it's the right. I have a feeling it's kind of right, but it might be out by some kind of a scalar factor.
Using that discrete formula as an idea, it just kind of makes me uncomfortable, I guess, since we have a continuous distribution.
Yeah, I
I'm
know.
trying
I
to.
know. Me too. Hey, it works though.
It gets the right answer.
Let me see. It does if I throw out the 1/2 in front of the U equation.
Hey, Phobos.
Hey, Phobos.
Hope hanging out with your friend was good. If you're done, you're welcome to hop in if you want. But if you're just chilling, that's cool too. It's going to. Oh, okay, we solved 16 with Gauss's law and 2-point charges. And we're now working on
32.
part B of 32, yeah.
We're doing all the problems that are powers of 2.
Yeah. Fantastic. Ooh, good luck with the job interview, Phobos. And no worries about, not having time.
A job interview. Good luck.
It's already charge queue. I kind of want to check the answer on this one because I feel like the integral of q dq from 0 to capital Q, I feel like it's going to be something like that, but I can't quite like put it together. But if it's your discrete way, then that'll be like kind of crazy too.
I'm trying to go back in the chapter to see if they had a where did they have that formula for potential anyway?
Somewhere later on. Yeah, but was that kind of caught me up too, where like you have one infinitely thin thing, and I'm interpreting as you're adding an even infinitely thinner layer onto that infinitely thin thing, basically. I don't quite understand it for myself, to be honest.
Well, it was already thin, but you should see it now.
Yeah. Just cut those electrons in half. Yeah, like the ring approach, like you're saying, I would understand more, but I don't think it's that either.
Yeah, because to make it work, I had to throw away the factor of 1/2 in front of that potential formula.
Hmm.
The whole time I've never liked that 1/2 in front. You know, it's always like just there to make sure we don't count things twice, right? Isn't it?
Yeah,
I don't know if
but
I don't know if I am counting things twice. I'm just saying the whole dq is what comes in from infinity, and the whole q is what's basically at the origin. And so I'm integrating q times dq, right?
maybe. I'm getting a little lost
Yeah,
in this, to be
maybe.
honest. Hey, warm-hearted American girl. You were sad, so you ordered so much fast food? That sounds like a nice way to fix it. Hope you enjoyed the food. What'd you get? Okay, I want to check the answer on this one. So I might be like scroll down just enough to see the start of it.
I think we got it. I feel confident.
I mean, maybe you got it. Popeyes, Taco Bell, McDonald's. Wow, that sounds delicious.
Wow.
Four Horsemen. Okay, I mean, well, yeah, we already did part A, so there's no field inside the sphere. It's sorting the external field, right? Okay. So we set up that integral right for part A, part B. They are doing work. Is the additional work needed to bring in from infinity? Oh, I think this is your idea, Fembox, but with integration instead of summation.
So, okay.
Okay, let's just see the entire thing. I can zoom in on it. The work needed to bring in from infinity. Oh, so that is using the kind of, it's just considering like two pairs. Yeah, it's approximating the initial shell as Q and approximating the new thing we're bringing in as DQ
Yeah.
and treating like both like point charges weirdly.
That's kind of what I was thinking. I was trying to think of it as doing it symmetrically, you know, so that So bringing this outside sphere in all at the same time, so to try and keep it all symmetric, so that that could be justified to think of it that way.
I guess so, yeah. And hey, Plaid JD, how's it going? I haven't done either of those tests. There's a streamer named Caceratops who's talked about doing some solves of those. I don't know if he's planning to do them anytime soon, but he's the one I'm aware of who I've heard of like talk of those specific tests. Okay. That's a really weird question to set up, but I guess I should have still thought about the work and just put the work in terms of DQ.
So what's the formula for work? It's an integral of the force times the distance, isn't it?
Yeah.
So how did they set up that equation 12.65 there? They use Coulomb's law. Did they use Coulomb? How did they get that?
Well, I think here they're actually using work in general is like the integral force times distance, but I think they're using the formula for a pair of point charges here. And one of those point charges happens to be dq, so they're like, oh, let's take that whole thing and integrate it from 0 to q.
Yeah.
That's my interpretation, at least.
Well, it's cool, but I don't think I get it quite 100%.
Me neither. It's a weird setup. I guess I'm trying to point out gets the same result, but it's not a very natural way to get there to me.
You got time for one more?
I think so, yeah. Maybe we can look towards the exercise or whatever these smaller problems are. I think I called out, what did I call out? 56, 58. In general, I like the ones that are like after 50.
Okay.
Okay, yeah, let's select flux through cube 56. One. We're being interested in doing this one. I have E dot dA over one face of the cube. Ooh. So this reminds me a lot of that flux through a circle problem that we did, I think, last Saturday. Maybe.
Oh yeah, that's right.
Yeah.
Yeah, that's right. And didn't it only depended on the angle or something?
Something I can't quite remember. So yeah, we could ignore the rest of the cube and just look at that one face that we're worried about. So we could take a point charge here. Oh yeah. Did they give us a name for the side length? Edge D. Okay.
D, yeah.
This isn't very three-dimensional, but and the point charge is Q. So we probably want to name a theta. And we're interested in E dot dA. A cosine theta. D over 2. And if that's the center, I guess we actually have an isosceles triangle. These are both D over 2. I didn't really draw it to scale, but... Hey, Brian. Part A doesn't look too bad on this one. Yeah, Phobos. I feel like I'm making it maybe too complicated. I think it's still going to involve an integral, though, isn't it? Because, yeah, the strength of the field is changing with theta. So E is going to be Q over 4 pi epsilon naught. The distance the bottom is always D over 2. The side depends on theta. So
Phobos has a good idea.
oh, really? Flux through the cube should be the flux through the circumscribing sphere. Oh, all right. You're right. We don't have to do this complicated thing, do we? Well, oh yeah. Oh my gosh, oh yeah, this is gonna be so complicated. We can just, we get the flux through the sphere, and for just one face, we divide it by 6, because superposition.
Yeah.
Okay. Thank you, Phobos, for saving me from that.
Yeah, Gauss's law. Wow. That's the reason it's a one-star problem, right? Otherwise,
Yeah.
if we didn't have Gauss's law, we'd be in trouble. We'd be in a little bit more trouble here. We could still do it, but you know, it'd be a 2-star problem then.
Yeah, I was just thinking it seems a little hard for a 1-star the way I was setting it up. Okay. So yeah, that's a sphere of radius. Oh. D over 2 and D over 2 for the bottom or for the legs of the right triangle. No, it's not the, oh my gosh, we have to figure out. Ugh. If that is D, and that is D, and that is D, the like right side is going to be D over 2. The bottom, we need to find the length of the diagonal on the bottom, I guess, which is root 2D. d root 2. So the length of the diagonal from Q up to a corner. Oh wait, no, over 2. Because the entire diagonal is d root 2, but we want half of it. Ugh. D root 2 over 2 squared plus d over 2 squared. Well, d can just come out from. It's not 8. Okay. Root 3 over 2d is the radius of the sphere. It's in total flux. Oh, is it? I was just wondering why I'm getting the radius, to be honest. Well, the field does vary with the radius. Or... Oh my god.
The field varies.
It's Q over epsilon naught, isn't it? Yeah, this is pointless.
Yes, yes.
E dot dA is Q over epsilon naught. That's all. Yeah, okay. You're right, Bran. I'm glad I chose the problem because I'm evidently not good at Gauss's law. Let me make sure I got that formula right. Q over epsilon naught. Because that's all the charge that we're enclosing. Oh, and that's not backseat away, Bran. The entire point is this to be a group discussion. Yeah, so we need to divide this by 6. I just want to make sure I'm not making a stupid mistake with Q over epsilon naught. Now we're good.
No, that's right. Q over epsilon naught, that's right.
I need to get back to the problem. Okay, 56. Cool. Oh no. Oh god. That's just gonna have to be the way it is. Okay. So if we want just a 6 of that, Q over epsilon naught for part A. Cool. What about part B? Charge Q is moved to one corner of the cube. And now what is the value of the flux E through each of the faces of the cube? And we're saying there's a similar trick. I feel like I'm gonna.
Yeah, I think I have an idea for that.
I feel like I'm gonna overthink it. Again. Because we have 3 faces where it's gonna be like parallel, and 3 faces where it's not parallel. I don't know if that really matters though. Like all the corners that Q is touching. What is this? I don't know what I just drew, to be honest. The perspective is so off. But a limit for a breaking point of a domain? I mean, I can Google. I don't know what that means, Alex, but I can look at it later. Let me see how what you do problems that require integrals. Yeah. Thinking along the right lines with this parallel and not parallel part. Okay. Like for each of 3 faces it's touching. It's just like the normal field, I guess. You don't have to do anything special with angles. Should I be going back to like thinking about a sphere? Well, it's not the same if it's not like Q isn't enclosed by it, I guess. Q is on the border.
Yeah, Phobos, I'm kind of imagining that little sphere Q now is kind of inside, because you could take that cube and duplicate it 8 times, right? And sort of fill up space so that the little Q would be partly inside all 8 of those cubes. That's how I'm thinking of it.
Wait, what? So yeah, we could
So
like build a bigger cube. How does that helping us?
yeah, a bigger cube that's twice the height and width and length. And that little cube is in the center of those 2 by 2 by 2 bigger cube, right?
Okay. So are we? I just want to call it 1/8 Q over epsilon naught, I guess. If we have 8 total cubes and we want the flux through just one of them?
Yeah, so 1/8 of the flux is coming through our cube. But now how much of that's going through each of the faces of our cube?
Oh, I guess we would divide it by 6 again then. Well, is it that simple? So I guess that is the entire flux. But for these like faces that are touching our point charge, the flux is 0 because they're perpendicular and cosine of 90 is 0.
Yeah.
So we only care about the faces that are not touching Q.
Yeah.
So we have the different values of the flux, I guess. 3 of them are 0.
Yeah.
3 of them, I guess, share this entire flux that we got.
Yeah.
So 1/24th Q over epsilon naught. Huh. That's Gauss's law is so weird. But I guess that makes sense. What's the other way, Brian? Oh wait, they don't provide answers for these problems. We could try Googling if we aren't sure, but... Oh god. Oh shoot, Nikita, I missed your message over on YouTube. Sorry about that. Yeah, I guess we thought we took that bigger cube, we divided it up into 8 smaller cubes. So we got that first 1/8. But we are interested in just the face through each one of that one cube we're interested in. So we had to break it out a bit more, I think. And hey, Sai, mechanics-based questions? I am so bad with mechanics, to be honest. I don't. I kind of want some confirmation on this. Let me. Oh, it sounds like we all agree on it, but a charge queue. I need the internet to validate me. Okay, they agree with part. This random site agrees with part A. Oh shoot! I hope they're gonna. I go with the first part because the second part. I'll just go with the second part. Well, let's go with this first.
Oh, that's a great way of thinking of it. Noble Penniless in chat has a great way of thinking. Yeah. Oh, and you found a picture of it too. Looks good. Yeah.
Each face. The face I already made it before one by one. Oh, nice, Brian. Yeah. That's a neat problem.
Saved by symmetry.
Yeah. Thank God I didn't get too far into that Coulomb slot integral. Or I guess it wasn't, or it was still Gauss's law, but like I was using the hard part of the Gauss's law equation. Yeah, I guess unless there's anything else for the day, we might wrap up the reading group part of the stream here. And see if there's a math question. Someone asked in YouTube chat if they could ask a question before, so we might have that to do.
All right, Don, I'm gonna hop off.
Sounds good, Fenbox. Thanks for hopping in.
Yep, thanks for having me on. Thanks for putting up with me, everybody.
Appreciate you. See you.
See you next week.
Mm-hmm. Okay. Yeah. I guess that for this situation, I was doing things the hard way initially. Let me update my title and stuff. Chat and internet. Math. Ugh, the category change never goes through if I do it too quick. Let me update my YouTube information. What? Close out of that. Get the new thumbnail. Okay. We're all switched over. If gravitons, oh, I didn't know that was a question. I wouldn't know how you figure that out. So Alex DeFlock over on YouTube, try doing the limit for breaking point of the domain. Does that mean something special, or is that just limit at a discontinuity? So I've done many of those. Breaking point. Does breaking point of a domain mean something special though? No. Okay. Yeah, I think I've done many of the things that Alex Spock is saying if I'm interpreting them right. Yeah, I was responding to what Noble Penniless or Brian said there in chat. I guess whatever that thing that detected a gravitational wave, like I assume that we would know based off that LiDAR thing, LiDAR, LIDAR, whatever. Okay, that's what I would assume. But by the way, I just like I know nothing about it, so I didn't want to like say it. um. I wonder at Quack if you're still here. I'm around to answer questions now. See if we can get Quack in here. Actually, you know what? I think today was gonna be the last day that we. I mean, I guess we could work on chapter 1 next week too, but like, I think we're ready to move on to chapter 2. So it's 3 weeks now on chapter 1. Theoretically, but they actually measured them supposedly. Yeah, I wouldn't know the first thing about it. And there's so many fun-looking questions. Like, I feel like I could spend a long time just on chapter 1, working through these questions. Oh, you know what? There was a question that was posted in my Discord yesterday. I think it's too late to tell the person. They said they only had an hour, and I wasn't doing math that day. Let's at least like take a look at it though. So we don't have anything else in queue anyway. Okay. Yeah, I think last week we said that we would we wanted to meet for like 1 more week, and this will be like the 1 more week, even though we don't have everyone here, but I think we can just get to the next chapter. Mass term in the Einstein-Hilbert-Lagrange chain will give a different equation. Oh. Those are definitely names in words. So this person has to find the surface area of A and B. Oh god. Well, we can figure out what the long side of A is, which would be our base. You know what? Finding A is not so bad, I think. This long side would be our base. We can find the height without too much of an issue. What about B? This is a parallelogram? And is this 44.7 meters the height? I have a hard time. I don't think it's the height, unfortunately. It looks slightly off. They made a miles-long tube and are waiting for a supernova or something to see if there's a difference. Is that the LiDAR thing? I think it's called, where they actually detected a gravitational wave. Yeah, I think it was like two black holes combining or like colliding is what they detected. Something like that. The error parallelogram has some like pretty nifty formula, doesn't it? Parallelogram. Yeah, I mean, I don't know either, to be fair, Brian. Base times height. Okay, that's nifty enough for me. Neutron star collisions? Oh, that would make sense too. Those things are super dense. So we know 13.2 for the top of that parallelogram. The height of this is going to be really annoying to work out. Like, I really want to say it was 44.7. Just to make my life easier. That's kind of lazy though. It's like some kind of like engineering drawing too. Oops. I feel bad because I did like the person said that like the person came in my stream yesterday and asked if I was doing math help because they had a question that's due in an hour. And I told them no, I'm not doing math help, but like I hate saying no to people who need help. So I think it's already like too late for me to have help this person, but we can always do something here. So we know the bottom left angle is 41. Just looking at A for now. And so I'm going to do... Let me... I just get the diagram in the on the screen. We're going to Pythagorean theorem with the 46.3 and the 46.3 to get this diagonal. Use your mobile app at McDonald's. Isn't it cheaper if you buy it through the app? Because they don't like actually paying employees. They rather people just order through the app. Well, isn't that just 46.3 root 2, I guess? I didn't need Wolfram Alpha for this. It's 46.3 root 2. FQ47. The employee's like, what'd you say to me? So what's that? 46.3 root 2, I said. Oh, you know what? I guess it's not quite as trivial to get the height of that as I thought it would be. We do know from the diagram what this bottom face would be, though. Which is what? 36.4 minus 13.2? Which is 23.2? So now with an angle and a side, this is the hypotenuse. We want the opposite of this thing, so we would say sine 41 equals height over 23.2. Just right? Let me plug this into for so 1/2 the base we said is 46.3 root 2. The height is 23.2 times sine 41. You think that 23.2 is horizontal? So I was doing this 36.4 down here, which is definitely, it looks diagonal to me, minus this 13.2 up here. Which I think is also at that same angle. And I guess I'm assuming that O star is equal to this same segment down here, but... I think what I've done is okay. .4, 13.2 are horizontal measurements. Well... Okay, I was thinking... it's diagonal because the top of this line is slightly lower than the top of this line. It kind of bleeds into the U star, so it's hard to see. O star, U star are at 4 degrees to the horizontal. Just make this big again. I don't trust you. Yeah. Oh, that's the 4 degrees to the horizontal. I completely missed that was there. But yeah, no, I'm thinking they're both tilted because like the end of this line is slightly longer than the end of this line as well. And so similarly with like the U and the U star. So to me that implies that it's with the 4 degrees. I might be misreading it or like, you know, misinterpreting that, but I guess it's maybe vague on that. I don't know. Yeah. In the physics world, we would just pretend like the 4 degrees isn't there. Or we would enclose it with a circle. Let's go with it. Yeah, because otherwise I don't, it's a much harder geometry problem, I guess. This seems more like it's something from an engineering class, just how the diagram looks. But I assume this is a problem that is possible. And it might still be possible even if those were perfectly horizontal measurements. But it's a much easier problem if they're diagonal, or like, you know, with 4 degrees from horizontal. So I prefer doing easy problems to hard problems, is what I'm saying. Wait, so I got a result for A when I plugged it into Wolfram. 498.3. 498.3. Okay. Now, how are we going to deal with this parallelogram? We know the top of the parallelogram. $13.2. We know what do we know? The difference with your interpretation is you would have to divide that area by cosine of 4 degrees. Oh, really? Okay. We could get the side length using law of cosines on the triangle. Does that help us? Yes, it does, because we know what this angle is 121. So that angle, or like that angle's the same, and these two angles are the same. And the angles have to add to 360. So 360 minus 242 is 118, and we divide that by 2 to get 59. I hope. That's the way to actually write it down. I can always check it at the end here, but I guess let's get the length of that side, and then we can figure out the height of this thing. We don't have to care about the 4 degrees with the way that I'm doing it, I guess. If I am doing it right. Anyway. Oh, who's that? Oh, Brian, thanks for the 10 bits. I appreciate you. All right, so the opposite from that, 41. Okay, so that, just call it C. C squared is equal to 46.3 root 2 squared plus 23.2 squared minus 2 times 46.3 root 2 times 23.2 times cosine 41 degrees. Wolfram, save me. Hey, praiseworthy MF. There we go. If 4 minus C equals 4, then what does C equal? I can show that quick. Before I move on. Before I get on with this problem. 4 minus C equals 4. What I would do here is get rid of the 4 that's over here. So we do that by subtracting 4 from each side. 4 minus 4 is 0, so we get just a minus C, because we still have that minus sign there. 4 minus 4 is 0. If you multiply each side by -1, just get rid of that minus sign, but C just equals 0. Wait, doesn't make sense, does it? Wait. Yeah, okay, yeah, C equals 0. So sorry, yeah. For a second I thought I did something wrong there, but no. What's going on with this law of cosines here? No worries. If you have any more questions, please let me know. And you don't have to do anything you don't want, but if you're interested in math streams in general, there's a couple people that I can recommend very highly. Just I'd like to let people who are new around here know that there's a little community of us out there. Oh, and thanks for the follow. 46.3 square root 2 squared is 23.2 squared minus 2 times 46.3 square root 2 times 23.2 cosine 41. That alert that just played, I have a few different follow alerts. That one that just played is from It's Always Sunny in Philadelphia. It's that episode where they give Charlie a pill. They tell him it's a pill that makes him smarter, but it's just like a placebo pill to see how he acts. And then that's from like the very end when it's revealed to him that the pill is just a placebo that didn't actually make him smart. Okay, so 50.3 is the length of that side. So he's saying stupid science bitch couldn't even make I more smarter. I was like, that's like the joke. We're like... Okay, so C is 50.3. All right, I need to check the angles that I got in the parallelogram. You know, I love It's Always Sunny in Philadelphia. I'm pretty behind on the new seasons, though. .360, good. Angles look good? Okay, cool. So the point of this... Just wasting beans, yeah. Oh no, Jed, that's the important thing. If we have a problem that you can, that you might like here. Do you find out of the measurements of the side lengths for the XY? So it's a little bit unclear to me. I might be misinterpreting what the question that you're asking, but I'm taking this 36.4 as the diagonal length, not the horizontal length. Like, because that little blue bar here it ends slightly lower than the blue bar over here, like it's following the slope of 4 degrees. Same thing with the 13.2 up here. This one ends a little bit lower than this bar over here. And that does make the problem easier to me, so. This 44.7, I'm just not planning to use it because there probably is a way to use it. I don't know, I don't think it's as clean as it's going to be the height of this parallelogram, though. I don't imagine it would be. Watch me get 44.7 at the end of this calculation. So, I got C as 50.3, which is the longer side of the parallelogram. I'm also assuming these things are parallel when they don't have to be, but I'm taking them as parallel. What's up, Jed? So yeah, I was gonna do, I was gonna get the height of this thing by doing, if that angle down there is 59, we want to do the hypotenuse of 50.3 times sine 59. Can you figure out the length of OU star? That's what I just did. Let me go back to the problem. So I focused just on the area A first. I found this hypotenuse from the 46.3 measurements that were like out there. And then I did law of cosines with these two sides and that angle to figure out that side length. And I assume this side length is the same as that side length for OU star. But yeah, I got 50.3. Well, I'm calling it a parallelogram, and they're the same sides. Oh wait, oh, I'm sorry. That's O star U star. You're right. Why do we need that? Sorry, I added a star mentally. Why would we need O U star? Hypotenuse. Oh, dude, that's an emote idea right there. I don't know exactly how it would look, but like hypotenuse. You know that it's the sum of two triangle areas. I feel like it's making it. I don't know what the height will be though. It's a weirdly shaped triangle. I like my way more because I as long as I can get the height of this parallelogram, I can just do base times height for the entire thing at once. Unless you're seeing an easier way. So I think I just found the. So 50.3 is, I'm saying the length of O unnamed point. And this angle here is 59. So let's do 50.3 times sine 59. And that's the height of this thing, 43.1. And now let's multiply the base, which is 13.2. 569. The person on Discord gets 520.1. Okay, so slightly different. Let me write it out. I might send the person a screenshot of what I've written on the board. So maybe I should write out the calculation I just did. Or write the Yeah, I always do everything right. So clearly. Yeah. D is equal to 50.3 sine of 59 degrees. What did you say that was? Like 41? $43.1. Uh, 43.1 times 13.2. That's 12.3. I want 13.2, please. 568.92. 568.9, sure. Rounded a bit different, who cares? Okay. So let's get a screenshot of my board to help explain what I did, but I'm going to need to write some text for sure. Mathematical presence just called eta, theta, beta, zeta. Sorry for the temporary echo. Let's bring Discord back up. Greek alphabet soup? Yeah. Oh, okay. Yeah, like I was thinking like that's from there's like a whole mess of Greek letters on the board. Um, A equals 498.3 and B equals 568.9 square meters. Now I want soup. At 36.4 meters and 13.2 meters are measured relative to the four. Oh god, I need a degree symbol. It's gotta be in there somewhere, right? Oh, I see it. Cool. Just I don't feel like doing LaTeX right now. Use the donut. Oh, is that the alt code like 135? Oops. I can't do alt codes when my OBS is open because I use alt numpad as hotkeys to change my scenes. Forgot about that. Dough, I messed it up. I get it. Dough, and Homer likes donuts. Either way, it's not on board. It got the long side length of the parallelogram by doing law of cosines to find the third side of A, which is also the long side of B. Then I use trig to find the height of the parallelogram. Then its area is just base times height. And I should escape these asterisks. Okay. $44.7 times 13.2. What's 44.7? Oh, the 44.7 was that like pseudo. I was thinking that height as relative to the Horizontal. Not the 4 degree. Yeah, because this looks like it's relative to the horizontal, not the 4 degrees. That's why I was avoiding it. Because it seemed like it's probably close to the height of the parallelogram. It's not gonna be exactly the height. I thought it was like 41 or something like that. Matrix logic for this problem. Oh. This person got back to me quick. I did an error with the 4 degrees. That's why I did not come to the right answer. Hey! Never question me again, okay? I'm always right. I'll take it, I guess. Can you tell us a math joke? Now I'm on the spot. I feel like I've told math jokes before, but now I can't think of one. Besides the classic, 7, 8, 9. No, I don't know. My mind just goes blank. I feel like usually my sense of humor involves reacting to something that's happening in front of me. So I need like to like read something that makes me think of a joke or something like that. Oh, awesome, Croc. Yeah, I'm sorry I couldn't help you out yesterday, but glad I was able to help you out now. Quick. Jed, are you around? If you are, I wouldn't mind looking through some like Reddit or something to try and find a question. If I don't hear back from Jed, we might do some abstract algebra. I'm probably going to stream for a ton longer, maybe like 20 or 30 more minutes, so. Until or unless I hear back from Jed, I'm going to start looking through the abstract algebra. Yeah, Croc, it'll be saved on Twitch for like 2 weeks or something until Twitch deletes it. But it'll be up forever on my YouTube channel in that first link there. Because I dual stream to Twitch and YouTube, so YouTube doesn't delete VODs like Twitch does. Oh god, I'm not going to scroll all the way down. What page is this? 80? Even further. We made a lot faster progress. I mean, I've had algebra also started earlier too. 150? 120? Nearly? 100. Okay, cyclic groups. Yeah, so I think this will be the time where I start to fall behind now Fembox, like I thought I would when this thing first started. I think Penthouse has kind of been picking up the pace. I might just get sick of chapter 4 and move on prematurely, but I don't know, it depends how much I want to keep up, I guess. Do I also treat field extensions? I don't know what those are, so I guess I don't. 7 to 11, 14 to 16. I don't remember where I left off last. Oh. It's a goat joke? Oh, okay. No, so I'm only just starting my like abstract algebra journey. Yeah, so this is a reading group that Penn Center is doing that I've been reading along with. Yeah, we're pretty early on in group theory. So I haven't gotten anywhere. I haven't gotten to rings yet, much less fields. Where are the problems again? 7 to 11. Do I recognize 11? No. Do I recognize 7? No. Wait, what? No way. I'm this early on? Oh wait, I'm looking. Never mind. I'm looking at the problems that Penn Center posted for chapter 5. Let me scroll up to chapter 4. 1 through 6, 8, 9. I've definitely done 9. 13 to 15. I've done that. Oh, I remember. I either left off on 15 or I did 15. I definitely tried it. No head retention of group extensions. Is that a joke that I'm missing? Where I don't know. Either way, I don't have anything to retain when it comes to groups. So okay, I think I did. Oh, it's just a rhyme. Okay. Okay, I think I remember doing maybe the first part of this because there was some argument where, oh no, did I do closure but not inverses? I'm gonna start 15 from scratch. I remember kind of how it goes vaguely, I think. I remember someone was helping me out with this one. Maybe underscore or someone. So G is abelian. And H is all elements G in G such that the order of G divides 12. Oh yeah, and this is where we're having way too many horizontal bars. Vertical bars, rather. Which degree do I have? I have a Bachelor's of Science in Applied Math and a minor in Computer Science. Which I feel like I'm underqualified compared to most people who are like come by the street. Okay, so first off, the order of E is 1. So the order of E divides 12. E belongs to H. H is non-empty. Now we're going to let A and B belong to H. That means the order of A and the order of B both divide 12. And so the argument for this was really messing with me. Yeah, I probably got stuck on this part of the argument because it doesn't feel like it should be closed to me, but it actually is, I think. Oh. Where are we going with this? Start with the inverse? Do you think that'd be easier? I mean, the inverse, I guess, is pretty quick. Since the order of A equals the order of A inverse, and the order of A divides 12, the order of A inverse also divides 12. So A inverse is in H. I think that's all you need to do for inverses, I guess. So the reason it doesn't feel close to me is that what if A is order 6 and B is order 3? My thinking was that 6 times 3 is 18, which certainly doesn't divide 12. But the order of two elements multiplied together isn't necessarily the product of their orders, or whatever version of the thing I said that actually makes sense. So maybe that's why this thing can still be closed. Let the order of A equal... All right, so let the order of A times K equal 12. The order of B times L equals 12. Equals 12 over K. The order of B equals 12 over L. I think we're going to consider AB to a power here. And we're going to be able to AB to the 12 squared over KL maybe? Because it's a billion, we can, well, we don't even need 12 squared. What am I saying? Just 12. This is a billion, we can distribute this power. Oh, fractional powers are bad. We don't know that 12 over KL is an integer. No, this is bad. We haven't defined fractional powers, and even then we probably wouldn't want a fractional power. You think it's the LCM of 6, 3? Okay, that would fix it. Oh, actually, I guess would we consider that here? Do we want AB to the power of the LCM of their orders? I think that was the argument. AB to the LCM of order of A, order of B? I don't know if that's gonna, no. How does that get us to the order of, to the order of AB dividing 12, I guess? Well, A and B, or the order of A and order B, are already divide 12. Their LCM, I assume, also divides 12? So if we can show this thing comes out to be E, which... Oh, you know, this is coming back to me the more that I do it. This isn't quite right. Or the book did it like GCD of LCM, or the book did it a slightly different way, I think. Let's follow this through though. So this implies the order of AB divides the LCM of this thing. But the LCM of A and B divides 12. So the order of AB divides 12 also. I think that's the argument that we can make. Hey, Lubert. You just consider AB to the 12? That's probably more direct, isn't it? Yeah, okay, that's fair. GCD times LCM is A squared B squared. I think it's just AB. I thought we proved that AB is GCD times LCM or something. Or maybe, no, LCM over GCD, probably. I don't remember how that thing worked. So what about... What you said might be true too. I just don't quite remember how that identity goes. So I assume 12 isn't special. Like 12 does have a lot of factors, but if we had like a prime number, it'd be the identity. Like if you had like say 5 as your order. No, I mean we didn't do anything that relies on 12 specifically. I think we're... Well, okay. Product of integers with GCD and LCM. It's really multiplied? That feels weird. Okay. So maybe I thought it'd be LCM over GCD. Because isn't the LCM at least as... Oh, okay. Yeah, I'm just crazy. Okay. I want to look at the answer in the back of the book for 15, though. So I think they did it a different way. So this is chapter 4, number 15. It's like 580. Not a bad guess. All right, 15. Scroll up so it's at the bottom. Yeah, Perjure is I was mixing up like how that works. Oh, they're doing like the one-step test. I guess that's quicker. And 12 is not special. One-step test, boo. It's pretty elegant, I think. It is a little bit, it does feel random for someone like me who doesn't understand the proof. Or looked at once, understood it, and then immediately forgot it. So that was 15, so 18 is next. Oh, I feel like I looked at 18. Yeah, I definitely did 15 and I moved on. I don't think I fully understood it though, so I'm glad I revisited it. um, so yeah, I want to re-figure out 18 as well, because this one was a very weird one. They're only equal. They're both infinite, which is the weird. Like a to the I and a to the j are both infinite because they're subgroups of an infinite group. So the order of a to the I is equal to the order of a to the j if and only if I and j are both not 0 or they both are 0. 0 is like I think the only trick in this one. Because if it's a to the 0, you can just get e and that's order 1. For anything else, your order is infinite. Okay, yeah, and it's an even number, so we don't know. You know, I can't look at the answer, but oh, actually, 19 is. I remember, yeah, because 19 is basically the same question, and it has one element of finite order, which is the trivial subgroup. Uh, 22 is next. Oh, man, okay, yeah, I did this one too. Apparently, I got more work done than I remember. Okay, let me look at the next one. I remember it was 22 because I don't remember how it goes. But what's 24? Okay, I have not done 24. I don't remember if I actually did 22 or if I started it and then I gave up. I definitely ended with 22. I think I did 22. You can eliminate. Like, I named my group elements as E, A, and B. And you can make the argument that A squared must be equal to B by elimination. The other two don't make sense. And I think that's how I made the argument for 22. What were you thinking, Brian? Right. I don't think we have I don't think we have Lagrange's theorem to say that yet, though. But like I think I was able to make a roundabout argument that basically came out to be the same thing. Because I think we have, for a cyclic group, we can make the claim. We have a theorem that says we can say the order has to divide the order of the entire group, but I don't think we have that in general. Screams Cayley table. Oh. Yeah, you can make a Cayley table. And you can do it like a Sudoku, I guess, where you're going to have just one thing and like just one missing square in like a row or a column. K table plus Sudoku skills, yeah. That's probably the easiest way to do 22. You know, let's just or the easiest way to do 22 for someone who doesn't have Lagrange's theorem anyway. I think there's been a lot of hype about Lagrange's theorem. It's not for another chapter 2 or 3 though. So yeah, if we let G be order 3, E, A, B. Set up a Cayley table. E, A, B, E, A, B. The E row and column is easy. That's apparently it's not easy enough. Jeez. Well, ooh. We need to figure out either. It's not as easy as I thought. Oh wait, well, this is either B or E, so we still have the same issue, I guess. Where we still have to prove that A squared is not E. Lagrange Roxy. That is the song, right? I remember that being in Guitar Hero 3. Can we say anything about A, B, or BA? I would expect it to be E. Or, you know, it does have to be E, but I think this is maybe not as direct as I thought it'd be. I thought we'd have something like, you know, I thought we had like a B there, and then this becomes super easy to just Sudoku it out, but I think you have to do some work still to prove why that's, or you know, if this can only be E or B with Sudoku skills, but you have to do some work to prove which one it is still. Right, yeah. That's the thing that I said. Yeah, A squared equals B, then AB equals B. Yeah, I figured that out somehow, I think. Or I think I said like if AB equals A, something bad happens. If AB equals B, something bad happens. So it must be that AB equals E. Yeah, if AB equals A, then B equals E, which is bad. If AB equals B, then A equals E, which is bad because they're distinct from E. So AB equals E. Okay, that's how the argument went. I already have a B in column 3. Oh, you're right, Fembox. I'm just bad at Sudoku. It has to be in that center. Okay. I'm too lazy to write it, but I remember I once wrote code that would solve Sudoku, and I was like, oh, this will be easy. Like, I know how to solve a Sudoku puzzle, so I just programmed it to do the same process that I do. And that code miserably failed on any, like, it could only do, like, the easy Sudokus. And it crashed and burned on anything that was called, like, medium or hard. Hey, SPQ. Yeah, you're right, Alex. It's not as much as I thought it'd be. You can't place B. You can't place another B anywhere else. Can only do one by one. Yeah, I mean a one by one Sudoku. I know that's still hard because how do you know it's 1 through 3 or 9, or how do you know which one of like 1 through 9 it is? I'm getting really hungry, but I do want to try like an actual new one I haven't seen before today. So let's look at 24. You can solve a one by one Rubik's Cube. That's pretty impressive. For any element A in any group G, prove that the group generated, or the subgroup generated by A is a subgroup of the centralizer of A. Oh, okay, that's fair. Why do we, yeah. Yeah, it does. I guess Sudoku would generalize. Like, yeah, you could have like a 10 by 10 Sudoku and have it be 1 through 10. I think the rules will still apply the same way. I don't know. Apparently, I'm terrible at Sudoku and I shouldn't try, so. For any element A in any group G, it's the subgroup generated by A is a subgroup of the centralizer. That's kind of crazy. Now, that's true, I guess. So the centralizer of A is every element that commutes with A. Have you seen Sudoku before worked in binary? I mean, yeah, if you only allow single digits, yeah. Yeah, Bladwy's doing physics, I think. Yeah, speaking. Oh. Is this not so hard at all? Because A commutes with itself. The subgroup generated by A is just powers of A. And A commutes with A squared. A squared commutes with A cubed. Okay, I think this is actually like not that hard of a proof. So we're in your master's dissertation right now. Ooh, cool. Happy to distract, I guess. Everything in a cyclic subgroup commutes. Yeah, that makes sense. So subgroup generated by A is equal to A minus 2, A minus 1, 0, A1, A2, da da da. How do I phrase this proof, though? Okay, let A to the K and A to the L belong to A. No. We only need one element. Belong to A with K not equal to 0 because that's trivial. Well, we tell we want to prove it for every K, I guess. Okay. I feel like I'm already phrasing this badly and I only have one actual word written. a to the k times a is equal to a to the k minus 1 times a, which equals a to the k minus 1 times a squared. And you can then take another power out of this a to the k minus 1. Oops. K minus 2 times a squared, which equals a to the k minus 2 a cubed. And this hidden proof by induction here. We can repeat this process until you get just a times a to the k. The k commutes with a for all k. Therefore, less than c of a. Okay. Oh yeah, let's hear it, Brian. Okay, 25 is next. An engineer, physicist, and mathematician are given 40 feet of fencing and asked to fence off the most area. Engineer makes a square. Physicist makes a circle. She makes a circle and stands inside. Declares he is on the outside of this fencing off most of the earth. True. I mean, I thought it was more of a... Yeah, I feel like you'd also say that about the physicist, I guess. I don't know. Either way, that's a funny idea. What's inside versus outside. D is a positive integer, D is not 2, and D divides n. The number of elements of order... Dude, I can't even figure out what this means right now. These frickin' dihedral groups. How does the Euler phi function work? That is kind of well defined due to the Jordan theorem. Oh, I haven't heard of that. Of course, it'd be a topology thing. I mean, that'll teach you to make a math joke in a math stream. It'll get analyzed to death. No, it's a funny joke, Brian. We just prefer to think critically about jokes and not just laugh. Like they're meant to be laughed at. The curve is regular, a continuous injective image of S1. Divides the plane into exactly 2 connected components. Side is well defined on the plane, not on a sphere. Bounded is the inside. That's a fair way to say it. Okay. Slitherlink puzzles? I never heard of those. Slitherlink. What? See, solved. Easy. You know, I don't know if I even want to know. I feel like my brain is already starting to shut down. The outside is bounded by infinity. True. You have to just actually laugh at a joke and not overanalyze it. Yeah. Sticky knows what's up. Or tell you how many edges touch that cell. Oh, okay. It's like some weird reverse Sudoku. Hey, Pen. Wait. Oh, yeah, so like there has to be a side on like this side or that side. How's it going, Pen? It's like that one seems like a gimme. How is it possible to solve these threes up and down here? It's 30 Celsius here? Oh my god. What is that in real units? Freedom units? Oh, 86. It was like 95 a couple days ago. What is that? 35? Okay. No stream today, I have to work at the brewery. Ah, dang. The loop can't branch. Oh, it has to be a snake. Like one continuous snake. I guess it is Slitherlink. Are these spaces without numbers just like free spaces? Planes start to say no to everything. Oh, jeez. A snake that's it's like, am I allowed to just like have fun out here and do whatever my heart desires? No clues there? Or you're just not allowed to have anything there? Okay, I don't, I'm getting distracted. I should do the algebra. So wait, wasn't the question again? It was some of the Euler phi function in the dihedral group. All the Euler phi function is every positive integer less than n and relatively prime to n. So we need to show that for a dihedral group, it's exactly phi of d rather than a multiple of phi of d. That's the task. And I think dihedral groups aren't cyclic because a single rotate will never get you a flip, and a single flip will never get you really any other flip or a rotate. I don't think. It does have a cyclic. True. Right. It's the minimum angle change and probably the maximum angle change too, right? So for a square, it'd be R90? Or how much you rotate a square by? Or R270? Okay. Positive integer. We are given that D divides N. The number of elements of order D. So all the flips are order 2. So we don't have to worry about flips at all here. The rotates that aren't the biggest or the smallest, besides R0. R0 is the identity, that's order 1. The flips also divide N. Or sorry, not the flips. The flips are order 2, which we're throwing out. The rotates for higher numbers of N, the rotates get a little bit harder though. Because it's going to be like a squared or like you only get like half the possible. How many rotative order 2 do you have? I guess it's always just 1 rotative order 2. But the square would be like 180. Oh, and you know, for a triangle, or I guess for an even N, you have 1. For an odd N, you don't have any? Is that how that works? No, it's gotta have 1. No. No. Okay, yeah. So D is a positive integer. Okay, so I want to look back at the table for Euler phi. So if we have what do we have? Okay, I feel like I'm starting to wrap my head around like how the dihedral group like just kind of generally behaves. Then how do we prove that it's not a multiple of phi of n? I guess is the issue. Yeah, there's 2 rotates that we can use to generate all of the rotates with a dihedral group. The smallest rotate that's not a 0-degree rotate and the biggest rotate will both get you all the other rotations. But rotates between the like the rotates but between the smallest and the biggest are going to have a smaller order. Oh, are there even more? I guess, yeah, like a pentagon. You might have 3 or maybe every single one. I'll get you where you want to go. Maybe I shouldn't be worrying about specific, like, or we know by this theorem that it must be a multiple of phi of d. We need to show that it's just multiplied with 1, though. How do we get there? That's because of that relatively prime thing, I guess. For D3 or D5. I guess D of a prime number would have all the rotates generating. A subgroup is a group. Theorem 4.4 wants to help. Well, we'd have to make a cyclic subgroup, I guess, because the dihedral groups aren't, like, generally cyclic. We could make a subgroup. It seems like that's what Penn Center is hinting at, too. What can R2 have? I assume that's 1? I don't know. Well, I mean, we could make a cyclic subgroup with any element we want, I guess. The most interesting ones, I guess, are the ones that generate all the rotations. All the other elements of the group itself are order 2. Yeah, all the flips are order 2, and potentially a rotate is order 2. Do we need, like, the... Where do they talk about dihedral groups? Like, they give a formula for what each of your rotation degrees are, depending on your value of n. Do we need to do something like that? It was, I think, in the table that this thing provides. Here we go. No, it wasn't. Never mind. How many rotates are there? What is the order? I guess I was trying to figure that out. It's like 360 over n, I think? I guess if you have a square, you do have 4 rotations, right? 0, 90, 180, 270. Okay, yeah, 360 over n is the number of rotates. That the dihedral groups are, they kind of hurt my brain to deal with. I'm so not used to them. Well, 0 has order 1, which that matches with phi of d, or, you know, phi of 1. We're not considering the rotate with order 2. You hate dihedral groups? Yeah. Yeah, sorry. N is the number of rotates. 0 is the smallest single. That's a better way of saying it. You like dihedral groups? I don't know. These things are weird. You have a subgroup, which is also a group of order n. Oh. And that will let us use the stronger version of the theorem. Rather, because I was thinking about using this, but we could convert it to doing something with this. So we can cover every possible element by talking about the cyclic subgroups that they generate. Because all the rotations are like self-contained in their own subgroup. Okay, so I guess okay, I think I see the idea where we have, if we think only about the rotations, we can make a bunch of cyclic subgroups that would get us to being exactly phi of d. How do we... I'm still confused on the mechanics of how we actually say this, though. The number of elements of order d in d sub n is phi of d. Okay, so maybe the idea is that all flips are order 2. Potentially one of the rotates is order 2. Now you consider the subgroup of every other, the cyclic subgroup generated by every other rotation. We know that the order of the subgroup is equal to the order of the element. And we know that it's a cyclic group. I think I'm saying more words than are necessary. of elements of order D in a cyclic group of order N. I think the idea is that the order of an element is equal to the order of the cyclic subgroup it generates. That's maybe the piece of the puzzle that I was missing. In the order of that cyclic subgroup is determined by phi of D. Is that everything that needs to be said for that first part? I'm too lazy to write it down, I guess, apparently. Not quite? Ugh, okay. I guess so, Brian. No, we don't have any sort of isomorphism stuff. Or direct product stuff, rather. In D sub n, all flips are order 2. If n is even, there is a rotate of order 2. Should I write down things that I know? Maybe that'll help me get there. The number of elements of order D in D sub n is phi of D. We need to prove, or we need to Dude, I don't freaking know. I'm about to call it, to be honest. I'm getting too hungry to think. Ugh. Freaking dihedral groups, man. I feel like I'm pretty, like, decent at things that don't involve the dihedral groups. I'm not even halfway through the list of questions for chapter 4. Let's call things there for the day, I think. So yeah, I'm gonna cut the YouTube stream off here. So if you're on YouTube, I appreciate you. I'm back on YouTube on Tuesday. Goodbye, YouTube.